Hello everyone. This video is for the Wednesday of the second week of class. And in this video, I will be introducing categorical logic, and in particular, what are the four types and four parts of a categorical statement. Now, just to give you an idea of where we're sort of at in the semester and where we're going. Essentially, what this class should be, what it should provide for you, is a set of tools to think about what makes for a good argument, and to give us some practice in being able to test whether an argument is valid or not. And when I talk about an argument, I'm not just talking about these versions of the argument that we're using at the beginning of this class, like all dogs are mammals, all mammals are animals, therefore, so on. I'm talking about like essays that you might encounter, op-ed pieces in the newspaper, just listening to somebody trying to persuade you of a political point or a religious point or a social point. Like, what makes a good argument? When I hear someone trying to change my mind and they lay forth a set of facts, and then from those facts they say, therefore, you should believe in this, what are the ways that we can sort of evaluate that? And this is, although this brings us to like many of the basic features of an argument, it's much more effective in being able to have an objective way of analyzing an argument than by simply asking, do I agree with this or not? Or does this sound right to me or not? We, after all, do want to have a method of evaluating an argument that can bypass our biases, our prejudices, our assumptions, and so forth. Okay, so in this video, I'm going to talk a little bit about the history of categorical logic. Not a lot. We'll just, dip our toes into it. And then give you some key components for understanding how these sentences work, the statements themselves. And then in the next few weeks, we'll be looking at the arguments as a whole. But we'll kind of, throughout this process, we'll kind of be jumping back and forth between looking at some things in the argument as a whole, going back down to the sentence and back to the argument, so that as we're learning about these different concepts and the different features of the argument, we can more easily see how it all kind of fits together. Specifically for you, like what is going to be on the quiz, what do I need to know how to do after this week? It essentially boils down to this. Keeping it simple, first I need you to be able to distinguish and explain the four parts of the categorical statement, and then to do the same for the four types of categorical statement. We'll get into that, what those are soon. Actually, I'll just give you a quick rundown. The four parts of a categorical statement. So when you think about our example, all dogs are mammals, you notice it has four words. That first word, all, which we sometimes see as, we also see other versions of this. We see all, no, or some. Those first three words are the quantifier. I'm going to go back a page because I actually have them listed here. That's our quantifier. The second word, dogs in this case, is the subject term of the statement. It's the first category that the statement talks about. And in fact, it's what the statement is directly discussing. So in all dogs are animals, all is the quantifier and dogs are the subject. The next word we have is the are, or are not. That's our copula. That's what couples the two terms of the two categories we have together. It says whether there is an overlap or disassociation. And then finally, we have our predicate term or our predicate category. In all dogs are mammals, the predicate would be mammals. As far as the four types of categorical statement, that's what distinguishes and I'll run through these really quickly, but then we'll get to them again later. We have four types of statement, A, E, I, and O. The A statement is all, S are P, S and P standing just for any term. The E statement is no S are P. The I statement is some S are P. And then the O statement is some S are not P. So each of those four different statements varies by the quantifier it uses and the copula it uses. Okay, next up, let's run through some, let's do a little bit of history here. Just a few brief words. Categorical logic is one of many different logical languages. Categorical logic is probably the most famous and the most influential throughout the world. It was invented and illustrated by Aristotle, one of the earliest Greek philosophers in the 4th century BC. So that's 2,300 some years ago. And it has become incredibly influential. It has touched not just philosophy and politics and ethics, which were core for the Greeks and the Romans as they were sort of building their civilization and constructing their laws, but it became very important. Using categorical logic became very important in having religious debates about the nature of God in the Middle Ages. And then it became still a core feature of how we understood the power of thought through the 1800s, certainly in the West, but then also any place that the West started to have a dialogue with. In the 1800s, we began, philosophers, mathematicians, and logicians started to find limitations to what categorical logic could do, and they wanted to find a more powerful language of logic. And a synthesis began to occur with categorical logic and other forms of logic. That essentially meant, categorical logic, it's like by this time, most people who use categorical logic thought that this was an incredibly powerful system, that there wasn't anything else to be done with it, like we've learned everything that there was to be learned, and that's the final word on logic. But by the 1800s, we started to have these ideas, like we can do more with this if we combine it with other kinds of logic. So categorical logic is still very powerful for most things, but it actually came to the question of, or I should say, one of the things that spurred an evolution in logic was the question of, can we build a machine that thinks? Or at least, can we build a machine that does all the things that a thinking thing could do? And for that, they wanted a sort of a language that can automate thought. In the 1800s, we had the designs for some of the first modern computers, except that they weren't electrical. They were run by gears and pulleys, wood and metal. The inventor, the mathematician and inventor in England, Charles Babbage, and his acquaintance, a woman named Ada Lovelace, built and programmed the computer. Charles was responsible for designing what the machine would be. And then the first computer programmer was Ada, who sort of put this language to use and melded the language with the machine to create at least a theory of something that ends up becoming the modern computer, all the way up through your phone. So it's kind of, I think it's fascinating how all of these little incredibly important discoveries, but so many thousands of them, had to come together to move from the ancient philosophers in India and Greece and elsewhere, thinking about what it means to think, what is a mind, what other sorts of things out there do think. And then from insight after insight, discovery after discovery in the sciences and mathematics and philosophy, bringing us to this modern age where we have machines that would be magical to anyone older than 20, who was around any earlier than 20, 30 years ago. Somebody, if you get someone who was around for the invention of the computer in the 1950s, they might look at a smartphone and understand that this is where it was going, but they would still be astonished. It would still feel magical. And if you got somebody who was around, like who lived 200 years ago, to look at one of your smartphones, they would probably think that you had a little demon or angel inside of there working its magic. But it's all down to the science. It's all down to people making discoveries and combining them and synthesizing them slowly over the ages to get where we are today. And I think it's one of the most beautiful things about the history of ideas. But we'll get into that another day. For now, let's look at let's test ourselves a little bit. So in a moment, not quite yet, but in a moment, I'm going to ask you to stop your video and see if you can figure out, just by the power of thinking, if these arguments, if these syllogisms are valid or not. But before we get there, I want to run through some things. So here we have examples of the categorical syllogism. A syllogism is a type of deductive argument that features two premises and a conclusion. Multiple syllogisms can be built on top of each other, creating much longer arguments that can be composed of hundreds or thousands of lines. There's no real limit to it. And I'll post a video later on where somebody breaks down this very long essay down into categorical syllogisms. It's pretty great. But for now, we're just going to look at the building blocks. So an example of a syllogism is the categorical syllogism that I've been using since day one, and it runs like this. I'll just keep using this as a basic reference, as a sort of idea anchor point. All dogs are mammals. All mammals are animals. Therefore, all dogs are animals. That's a categorical syllogism. It is based from three categorical statements, two of which are premises and one of which is a conclusion. Now let's turn our attention to this page we have in front of us. In the first argument, you'll notice that, first of all, I have the top two lines labeled as premise 1 and premise 2. Then I have a horizontal line, with the third line being labeled as conclusion. This is standard. So after this point, you can always, when you look at the other 5 arguments on this page, you will know that the first line is always premise 1, the second line is always premise 2, and that last line beneath the line is the conclusion. Another feature that you'll notice is that instead of words for terms, for categories, we simply have letters. P, S, and M are the standard letters that we will use. These letters can be used to stand for any imaginable term. What's important for us is never the term itself. It's always the structure of the argument. So this could be about, this first argument could be about dogs, mammals, and cats, or dogs, mammals, and reptiles. Or it could be about lawyers, trials, and judges, or something like that. It doesn't matter what it's for. And so we can use these letters just so we can focus on the argument itself. And later in the semester, we'll work on like translating between actual arguments we might find out in the wild, natural arguments, versus these sort of abstracted ones. Another feature that you will notice is that in every categorical statement, in each line, you always have 2 and only 2 terms. A categorical statement essentially relates the connection, the association, or disassociation of 2 and only 2 terms. Okay. But the argument, as opposed to a single line, the argument will always have 3 terms, each term repeated twice. So if you look at argument 1, you'll see that the P is in line 1 and line 3. The M is in line 1 and line 2. And the S is in line 2 and line 3. You'll notice that for every one of these arguments, each term is repeated twice. And that means that every single line is going to have a different combination. Ultimately, every pairing is discussed at some point. The premises connect one set of terms and another set of terms, and there's always going to be a common term. That's the M. In fact, the M always is going to stand for our connecting term. It's something called a middle term. We'll get into that more next week. Essentially then, premise 1 connects the P to the M, and premise 2 connects the S and the M, which means that through those 2 premises, we can connect the S and the P, and the conclusion will always bring the S and the P together. Now, the question is, whether or not those two premises fit together well. If they do fit together well, and the conclusion expresses that connection, we essentially get a valid argument. If that connection doesn't fit together well, and it doesn't bring those two terms together, the P and the S, then we get an invalid argument. That's one way of talking about validity or invalidity, although I don't think it's as clear as simply saying that a valid argument is one in which the conclusion necessarily follows from the premises, or if the premises are true, then the conclusion must be true. All right. Well, let's get to it. In a moment, I will say pause the video. When you do that, write down your answer for each of these 6. This is not a test. I'm not grading this, obviously. And when you're ready again, press play. And at that point, I'll go through the answers. If you have questions about this, put it on the discussion board, leave it in the comments on the video. I'll turn them on this time. I didn't realize I had to turn them on last time. Or save them for next Wednesday, and we can go through it then. Okay, ready? And pause the video. Okay, so by now you should have paused the video and figured out whether each of these arguments was valid or not. Let's go through these. So the first one is valid. All P are M, no S are M, no S are P. That is valid. Number 2, that is valid. Number 3, invalid. Number 4, invalid. Number 5, valid. And number 6, invalid. All right. If you got those all, great job. If you didn't, that's okay. One of the core things that we're going to be learning is a set of methods, a set of techniques where you can test out the validity of an argument without like breaking your mind over it. A set of techniques that allow for a reliable, it was almost going to feel like cheating to figure out whether these arguments are valid or not. But before we get to those methods, we have to learn some building blocks. Okay. Just a couple of quick notes. The first one we've already covered. The second one, this is an insight that was made by Aristotle. If these sentences sound kind of artificial, I mean, they are artificial. In the same way that if you think about a piece of sheet music, you know, where that has the scales and all the notes and everything like that, that's an artificial language for music. Music doesn't need the sheet in order to be music. If you're just singing in the shower, that can be expressed in a sheet, but it's not a sheet itself. The music is not the sheet. Just like the argument that we find in natural language is not the same thing as the standard form. In this case, the standard form of an argument is similar to the sheet music. It is a formal structure that we can use to understand every little aspect with clarity and objectivity. Okay, so one of the great insight that Aristotle had was that no matter how unusual the statement is in the natural language, and by natural language, I simply mean the language, the ordinary language that normal people speak normally in everyday circumstances, almost every statement can be expressed as a standard form statement. So for example, if we say, politicians lie, that can be translated accurately as all politicians are people that lie. If I say, you know, dogs make great pets, that can be translated as all dogs are animals that make great pets. Proper nouns, the example that we had from class the other day was Minneapolis. We might reference a single person like Abraham Lincoln. We might reference myself, you know, to say something, I love ice cream. We can properly translate that as all people that are me are people that like ice cream. But we'll get into the nuances of proper nouns another day. Okay, so here's some examples. Why don't you give it a shot? How would you translate these? If you'd like, pause the video and see if you can figure it out. Go ahead and pause it. Okay, maybe, so you've paused the video or looked at these and tried to translate them. The translations for these might go like this. Games are fun. All games are fun activities. Number 2, not all video games are fun. Some video games are not fun activities. The third one, in the USA, you must be 18 years of age or older to vote. Could be translated as all people in the USA who are eligible to vote are people 18 years of age or older. Because those are almost identical categories, people who are eligible to vote in the United States and people 18 years of age or older, actually I wasn't thinking about a few different cases, but for the most part, you know. Actually, yeah, this is all people in the USA who are eligible to vote are people 18 years of age or older. Yeah, that's true. But you couldn't actually say all people 18 years of age or older are people who are eligible to vote, because there are some cases where you're not. If you're not a citizen, for example, or in some states, if you are a felon, you're not eligible to vote. Okay, this is my handwriting version of this. So there are 4 basic ways. And for now, I want you to focus, I'm going to talk about the versions on the left, but let's look at number 1 here. There are 4 basic ways the 2 categories can connect. The first one, in something like all dogs are animals, all S are P. What we're saying is that every single thing that is in the category of S is also in the category of P. This diagram here in the upper left, it's supposed to represent that every single thing in the S category is inside or belongs to every single thing in the P category. So every dog is a mammal, but not every mammal is a dog. Okay. Another way of showing this, but don't worry too much about this now, but if you want to get ahead a little bit, another way of doing this is in a formal Venn diagram. So this might be an informal Venn diagram. This is more of a formal one, where we always draw the 2 circles overlapping. You'll see in all 4 of these, we have the overlapping 2 circles instead of drawing the circles in different relationships to each other. But in this case, we shade any part of the dogs that are outside the mammals, and that essentially says this doesn't exist. The shading says that area doesn't exist. In the second group, this is something like no cats are dogs. In other words, these 2 categories have no overlap at all. This is the no SRP. Number 1 is all SRP. The S's are inside the P's. Number 2 is no SRP. They are totally separate categories. Okay. The formal way, we'll get to this later, but the formal way of dealing with this is by, in the overlap, you shade it out. That says there's no such a thing as the overlap. Area 3, this is something like some SRP. Some dogs are friendly animals. Some dogs are animals with black fur. We're saying that there's an overlap, but not all dogs have black fur. Some dogs have black fur, some dogs do not have black fur. In the formal way of expressing it, instead of shading, we'll put an X for the some statements. This says there's at least one dog that is an animal with black fur. And then finally, some S are not P. Again, I think that we would have overlapping circles here, but the formal way of doing it is to put the X for dogs outside the X for animals with black fur. So we have these 4 different ways that categories can be related or not. Okay, here we get to the meat of the discussion. This is the thing that will be on the quiz. As I mentioned earlier, every categorical statement has 4 different parts. The quantifier, which says how many of the subject category are being related to the predicate category. We have 4 different quantifiers: all, no, and some. When we say all SRP, we're saying that every member of the S category belongs to the P category. When we say no SRP, we're saying that no member of the S category belongs to the P category. When we say some S, and I won't go through the two different versions of it, but when we say some S, we're saying at least one, possibly more, maybe even all members of S. The subject, so the second part of the standard form, is the subject, which is simply the first term or the first category, like dogs. The copula is either are or are not. And the predicate is simply the last term. Finally, we have our 4 standard statements. Now, this is something that you will need to memorize. We're going to be building on these. We're going to be talking about the relationships of these again and again in the coming weeks. So it is important to sit down and memorize these. It's not a lot to memorize. You know, it's not like a huge list of dates and facts or anything like this. It's just 4 basic lines. Our first type of statement is the A statement, all SRP. The E statement is no SRP. The I statement is some SRP. And the O statement is some S are not P. There can be no variation to these, except with the one possibility of when we're dealing with singulars, all S is P or something like that. If we say, something, it's not coming to my mind right now, but it doesn't matter. Sometimes the R will be replaced by an is. That's just the difference between singular and plural. But you'll never find in proper form all S are not P or not all S are P. Those are just those are not standard form. These 4 formulations are the only 4 formulations you will find. Why are they called A, E, I, and O? It's a question we often get. I was very curious about it myself. It's not because they're 4 vowels. It's not because they're the first 4 vowels. If we had a 5th one, it wouldn't be labeled U in all likelihood. It's simply because of this, that in the Middle Ages, the 2,000 years after Aristotle invents categorical logic, the scholastic philosophers and theologians of the Middle Ages, from around the 1000s to the 1500s, especially in the 1200s, 1300s, these scholastic philosophers revisited and reawakened this ancient Greek philosophy. And they constructed all kinds of learning techniques, tools to help students memorize these concepts so that they can essentially use all of these for the sake of arguments. They thought this was going to be an early stage of enlightenment or something. To help us remember how to catalog these statements in our mind, they decided to ascribe to them letters that are found in the 2 words affirmo, which means affirmative, and nego, which means negative. Taking the first vowels of affirmo, A and I, are for the A and I statements. Now take a look at the A and I. These are our 2 affirmative statements. In other words, they are affirming the connection, some overlap between the S and the P. With all S are P, every single S is a P, and so forth. With the 2 negative statements, E and O, we're talking about how those categories are not related, how they're disassociated. These are E and O, the first 2 letters of the Latin word for negative. In addition to that, so what's important, the takeaway here is that we have 2 of these statements that are affirmative, A and I, and 2 of these statements which are negative, E and O. We also have 2 different statements that are universal. And when I say universal, what I mean is it talks about every member of the subject category. That's A and E. In the case of A, it's pretty obvious. All S means every single S, every member of the S category. In a way, the E statement is also saying something about every member of the S category. In other words, it's saying every member of the S category is outside the P category. It's still universal for the S. Every single member of the S category is outside the P category. The I and the O, on the other hand, are our particular statements. In other words, they deal with only one or more members of the S category. Some S are P, we're saying there's at least one S that is a P. And some S are not P, there's at least one S that is not a P. So in Latin, nouns, it doesn't matter if it's the first word of a sentence or not. In Latin, the first letter of every noun is always capitalized. So affirmo is a noun. The first letter is capitalized, A. With the A, because it's capitalized, we can remember it is universal. I is lowercase, so it's smaller, it's particular. That logic doesn't apply nearly as well for the negative, for nego, since E is not the first letter of the word, but it is at least the first vowel. So remember, it's like a mnemonic technique. It's a tool to help us remember what these terms are for, but the E is the universal and the O is the particular. Okay. So that's basically today's lesson. This will be covered on the quiz for this weekend. In the next few weeks, we're going to be building on this. We're going to be learning more about how these statements are related to each other. We're going to be learning about something called the square of opposition, which sounds exciting, and it really helps us learn the patterns behind these different terms, these different statements. We'll spend some time translating natural language to the formal categorical language so we can see how this is a little bit more, can be put to practice when we are evaluating arguments. And then most importantly, this is all leading up to learning about some rules and techniques so that we can look at an argument like we saw earlier and be able to figure out whether these arguments are valid or not without breaking our minds over it all. It is also going to be an effective tool when we're trying to analyze massive groups of arguments. So yeah, that's it for today. Let me know if you have any questions. Remember, we have the discussion board, you have my email address, and of course we have next Wednesday's class. As a reminder, there is no class on Monday because of Labor Day, and Wednesday we will have a live class followed by another live class 2 Mondays from now. All right, take it easy. Good luck on that quiz. That's all.